Gappscan, plug-and-play micro-crack detection system developed by Easytesters. In this video, we are going to take you through the procedure of operating the Gappscan testing system to detect defects within a heat exchanger which may cause cross-contamination of the product. The procedure is in sections as shown here. All equipment required to carry out the test procedure, apart from the liquid side hoses and multi-fit adapters, is located inside the black box. When transporting, ensure that no sudden shocks are encountered, as this equipment is to be treated as fragile. The black box is labelled, showing the serial number, ID, calibration and expiry dates. Do not open the box in damp or wet areas. Inside the black box, on the left-hand side, is the transmitter unit. This is fixed and it should not be moved. On the right-hand side, the control unit is located inside of the soft bag. You will also find the battery charger unit and leads. The battery charger is fitted with a standard 240 volt plug, although 110 volt may be used with the relevant plug for country fitted. Connect the lead from the black box to the control unit first. Then the battery charger connection to the black box. The unit should be connected for at least 4 hours, ideally overnight, to apply a full charge from empty. This should last for approximately 10 hours. The switch should remain in the on position unless the unit is in storage. Do not attempt to charge the unit during a test. Press the I/O key for 2 seconds to switch on the control unit. You will see the expiry date. Always ensure that this is within date for testing, as when expired it will not work and should be returned for calibration. You will see the battery life and the serial number. This is the firmware level, which is the version of software that has been installed. You need to make sure that you are in a good position with the control unit in order to get a GPS signal, as the test will not commence without GPS. You can go outside to get this fix. Switch on the unit. Place the unit face up. In the bottom right side of the screen, you will see 2 ticks appear when GPS has been fixed. This may drop to 1 tick when inside, but the control unit will still operate with 1 tick. When you press the return key as indicated, you are allowed to scroll through the application. Select Records to move into the Records section, or Mon Test to move into Monitor or Test mode. In this screen, you can scroll through records from previous tests. Select plus or minus to navigate to a specific test. The test number is displayed in the top left-hand corner. Press the I/O key to see the size of the defect. To return to a record from the defect size, just press I/O again. To delete records, press the return key and the I/O button at the same time. Select Single to delete the current record, then confirm by selecting Yes. The unit shows that record 19 is now empty. Scroll up to the next record. To delete all the records, press the return key and the I/O button at the same time as before, but this time select All and then Confirm. Select Mon Test and then Monitor for the monitor mode. This allows you to monitor the test parameter and see when stabilization has occurred and the test is ready to start. This is an example of the screen that you will view in monitor mode as the pressure is stabilizing prior to running the test. Starting from the top left, the screen shows P, which is the pressure of the closed circuit, T, the target pressure, usually set to 3 or 5 bar, M, which is measured flow over the test period, A, pressure of an internal vessel within the Gappscan unit. This needs to be higher than the highest pressure from P or T to balance the pressure between inlet and outlet. G and W are the inlet and outlet temperatures, which are not that important. We do keep a record of these though, as if, for example, someone accidentally put steam into the system, we'd get really high temperatures and a false reading, but we'd be able to see why. I indicates whether the valve within the Gappscan unit is open or closed. To abort a test during test mode, press all 3 arrow keys at the same time to return to the test monitor screen. Press the IO key for 3 seconds to switch off the control unit. The heat exchanger should be filled with mains water and the valves locked before connecting the Gappscan unit into the circuit. Fix the multi-pit adapter to the water inlet of the exchanger. Tighten the bolts until it is flush to the pipe with no leakage. Open the outlet valve. Attach mains water to the inlet valve, then open the inlet valve. The mains water should be capable of providing over 3 bar of pressure, but no more than 10. Turn on the mains water. Check for leaks at the multi-pit adapter. Tighten with a wrench as necessary. Now wait for the exchanger to fill up. When full, the water will release from the outlet valve. Close the outlet valve. Close the inlet valve. Turn off the mains water, then disconnect the hose. To check there are no leaks within the Gappscan system, you should run a test using a stop valve. When carrying out the test procedure, it is important to have the black box in an upright position where it cannot rock or be subject to vibration, as shown here. Connect main water via the inlet valve. Connect the stop valve. To turn on the unit, press and hold the switch for 2 seconds. Fill the unit with water from the mains tap. Put the control unit in monitor mode by selecting Mon Test, then Monitor. Open the stop valve to allow the water to flow through the unit for about 1 minute. On the control unit, you will see the pressure dropping. Open and close the stop valve to extract any air from the unit. Leave the valve in the closed position and the pressure will start to build until it reaches the target of 3 bar. The internal valve may be heard modulating the input supply. When the live variable pressure P and the target pressure T have stabilised to within 2 decimal places, you are ready to start the test. If P does not stabilise, it usually means that there is air in the system, so you would have to bleed more water through and start again. Press the return key, then select Test from the menu. When Test is selected, an automatic sequence begins. The test time will be seen incrementing in real time until it reaches 5 minutes. When complete, the monitor will switch to the individual test screen shown here. Press the I/O key to display the test data. A hole size of less than 5 microns will determine that the Gappscan system is not leaking. Connect the mains water to the Gappscan inlet and connect the outlet pipe using Nitto fittings rated to 10 bar. These tubes should be tested regularly at 15 bar to ensure no leakages are detected from the fittings, as this may affect the Gappscan results. To turn on the unit, press and hold the switch for 2 seconds. Turn on the tap to flow water through the Gappscan unit for around a minute. Then reduce the flow from the tap to a trickle. Connect the outlet into the heat exchanger and open the valve. Put the control unit in monitor mode by selecting Mon Test, then Monitor. Look for any external leaks with a torch. Turn the mains water on full again. Open the outlet valve of the heat exchanger fully for 20 seconds to extract any air. Then reduce the valve to a trickle before closing it completely. The pressure will start to build in the exchanger until it reaches the target pressure. The internal valve may be heard modulating the input supply. On the control unit, you will see the live variable pressure P increasing to the default target pressure T of 3 bar. When P and T have stabilised to within 2 decimal places, you are ready to start the test. If P does not stabilise, it usually means there is air in the system, so you would have to bleed more water through and start again. Press the return key, then select Test from the menu. When Test is selected, an automatic sequence begins. The test will complete when either the measurement has reached a loss of fluid of approximately 18 millilitres or the test period of 5 minutes has elapsed. The test time will be seen incrementing in real time. To abort a test during test mode, press all 3 arrow keys at the same time to return to the test monitor screen. Depending on the condition of the exchanger, you may want to run the test at a higher pressure. At a higher pressure, the crack will open up more and therefore be easier to detect. If there are no external leaks, you would want to do the test at the highest pressure possible. From monitor mode, press the I/O key. You will be asked if you want to change the target pressure. Select 5 bar and then confirm. You will see the live pressure P increasing. In this case, it does not quite reach 5 bar as the maximum mains water pressure is nearer to 4.9 bar. Press the return key. Select Test. Press the I/O key. You will be asked if you want to use the current pressure. Select Yes. Once stabilised, the test will run automatically. You can see it is failing more quickly at the higher pressure. If the heat exchanger shows a defect above 20 microns, it is important to know whether this relates to one major defect or several minor defects, and testing at a lower pressure will assess this. You can also use the lower pressure when the leak is discovered to be so large that the test period would be unreasonably short. At a lower pressure, the rate of loss should be lower and so the test period will be extended. The control unit is in monitor mode. Open the outlet valve on the heat exchanger to release water, which lowers the pressure. As P is approaching 1.5, reduce, then fully close the valve. Press the return key. Select Test. Press the I/O key. You will be asked if you want to use the current pressure. Select Yes. Once stabilised, the test will run automatically. When complete, the monitor will switch to the individual test screen shown here. Press the I/O key to display the test data. You can see that the defect size at this lower pressure is 17.9 microns, which suggests several defects. If the live pressure P does not stabilise within 2 decimal places of the target pressure T, as shown here, then it usually means you have air in the system. Open the outlet valve on the exchanger to bleed water through. The pressure drops. Close the valve and the pressure builds again and should stabilise. If, when in monitor mode, you see maximum displayed at M, the measured flow, it means there is an airlock in the Gappscan unit. To remove this, simply turn the unit upside down as shown here. The unit will make this sound and maximum should disappear from the control unit. When transporting the Gappscan unit, you must remove liquid from the internal components. First, switch off the sensor transmitter unit. Place your finger over the outlet nozzle. Switch on and wait for the LED light to come on and go off. Then remove your finger from the outlet and wait until all the water has extracted. Open the Gappscan application on your PC. At this point, it will show device is not connected. Switch on the control unit. Plug in the USB lead from your PC to the control unit. The application should now show device is connected. If this doesn't occur, unplug the control unit for a few seconds and then try again. Now select Test Data and Upload All from the menu. As the test data is uploading, you will see the test records turn from pink to red. Any empty records are white. You can see the empty record 19 is the one we deleted from the control unit earlier. Click on the individual record to see the test data. On the left-hand side, you can see the results. Test serial number, test date and time, test duration, GPS coordinates, test pressure, test temperature, and the leakage rate with estimated hole size. The graph shows the leakage rate over time. The equipment status is also displayed. You now have the option of printing an individual test record or saving an individual record. To save all the records you have uploaded, close the individual record and go into File, Save All Uploaded Test Data Records. Select where on the hard drive you want to save and name the file. When all have been saved, the records turn from red to green. It is now safe to delete these records from the control unit. From the tests we conducted today, you can see that at pressures of 3 and 4.9 bar, the estimated hole sizes are larger than 20 microns. We investigated further by running a lower pressure test at 1.5 bar and the estimated hole size is 17.9 microns. The defects are thus multiple and within acceptable levels at the lower pressure. The criteria for determining if a heat exchanger has failed the Gappscan test is minimum test pressure of 3 bar not achieved, possibly due to poor seals. Consistent flow during test period showing defect diameter more than 20 microns. If there is a defect below 20 microns, the client shall be offered more frequent testing in order to monitor the defect for propagation into the rejectable defect zone more than 20 microns.